Computer Chronicles is brought to you by RonDiamond.com, the oldies site on the internet. Music and memories from the 50s, 60s, and 70s, not just another jukebox. Additional support comes from the law offices of Ivan Hoffman, lawyering with integrity for internet law, copyright, trademark, and other intellectual property law. And by TechWeb for up-to-the-minute technology news. Hi, and welcome to this special edition of the Computer Chronicles. We are on the island of Maui in Hawaii, and you may ask, why are we doing a high-tech TV show in Hawaii? You will be surprised to find out that there are quite a few innovative high-tech startups here in the 50th state and many well-financed, cutting-edge research and development projects here. To some, high-tech in Hawaii is an oxymoron. Hawaii is all about relaxing, sitting on the beach, while succeeding in high-tech is all about working your butt off. But times may be changing. Hawaii has many assets for high-tech success, a well-educated workforce, a high degree of computer literacy, and a desire to wean itself from depending solely on agriculture and tourism. Here in Maui, a high-tech startup called Trex is a typical example of Hawaii's newfound tech sector. Technology first developed to help the military look at ballistic missiles is being adapted to create a new generation of high-resolution digital video cameras. This digital photography technology developed to wage war is also being applied in another way: low-cost mammography machines for screening breast cancer, and new filmless X-ray machines that can be taken into rural areas or into third-world countries. Trex is located here in Maui's new Research and Technology Park, home to several high-tech startups. Trex, like many technology companies here in Hawaii, started out as a division of a military contractor. But Trex is now a spin-off focused on using its technology to develop commercial consumer products.
Our big thrust of our effort is to put out a commercial product. And what we've identified, we have a technology that's patented that gives higher performance, lower cost than what you can find elsewhere on the market. And we're pushing that into an area that we think has a very good shot at becoming profitable, and that is we're building video frame rate CMOS sensors. Because of our high sight technology, our thin film coating technology, we can achieve lower costs and higher performance than other people. So we think we have an advantage in the commercial arena there.
While Hawaii may not have the sources of venture capital funding that you would find in the Silicon Valley or in the Boston area, it has something even better: the Defense Department's R&D budget.
We were able to take a government-funded contract and in some sense leverage that as capital investment in the technology. So what it helps us as a company do is sort of use government funding to pay for some certain NRE, non-recoverable engineering charges, consider them as in a way similar to a venture capitalist, except they don't take stock.
One of the challenges for any high-tech company in Hawaii is finding qualified engineering staff. But here at Trex, they say it has not been a problem. Paul Johnson cites one example.
Two guys come to mind that we've hired from Silicon Valley. And one of the guys is just into windsurfing. And of course, this is the windsurfing mecca. So he was an easy sell. I mean, plus he's technically the right qualified guy. Otherwise, we wouldn't have hired him. So he came here because he liked the environment and the job. Another fellow we hired who was already living here, and he had relocated to Maui to the Bay Area a year or two before we showed up here, and was, well, I don't know what he was doing actually, but we ended up hiring him as a software engineer, and he had just wanted to get out of the Bay Area.
However, it's not always that easy. There is still a prejudice about Hawaii, and some potential employees, even Paul Johnson himself, worried about what a job in the islands might look like on his resume.
I was concerned it'd be a dead end career-wise to come here, because I wouldn't have the opportunities to move down the street, to interact with the people in the Bay Area or in the other areas of San Diego where the technology is being developed. But internal to our company, there are some very smart guys, and I'd say we got, to start our office over here, we got probably the five, in my opinion, the 5 best guys in the company to form the core of our office here. And with that bunch of guys moving here, I had no concerns anymore that this wouldn't be an ongoing viable operation.
One of the reasons Trex is here in Maui is its proximity to this wonder of technology, the AEOS telescope at the Air Force Research Lab. AEOS, AEOS, is an acronym for Advanced Electro-Optical System. The telescope and the lab are located in an area of Maui dubbed Science City. It's high atop Haleakala crater, 10,000 feet above sea level. The facility is primarily used for space surveillance. It's pretty much above the clouds, and it enjoys Maui's pollution-free atmosphere. The Air Force uses the telescopes on Haleakala to take extraordinary pictures of space objects. This, for example, is a picture of the Hubble Space Telescope in orbit around the Earth. The image processing you see here, called multi-frame blind deconvolution, takes 30 minutes per frame and does a fair job. The picture on the left is the original image. The picture on the right is the processed image. But that was a few years ago. The newest technology here can get you resolution like this, and it only takes 1 second per frame. This is the original image. This is the processed image. Original, processed. The AEOS telescope here at the Air Force Research Lab is one of the newest and most sophisticated telescopes in the world. Its specialty is tracking low Earth orbiting objects, such as satellites and other atmospheric space objects, like missiles. Another reason these telescopes can provide such clear pictures is the use of a computer-based technology called adaptive optics, which can literally stop stars from twinkling.
The light that comes in, we perform what we call adaptive optics on this light. Light from a star, as you well know, will twinkle as it comes through the atmosphere. The atmosphere distorts the wavefront. We sense that wavefront at the telescope, and we have a deformable mirror that takes the bend out of that light to give us a nice wavefront again to our sensor. So we can take the twinkle out of the stars, we can take the degradation out of that wavefront, and so that we get an accurate image.
The Air Force's incredible ability to track and follow fast-moving, low Earth orbiting satellites has many potential applications. In one miraculous feat, they were able to aim a laser beam at a satellite and reflect that light from the moving satellite down to a stationary 8-foot wide target on the Earth.
It's a very difficult challenge. The pointing accuracies that you have to have of the ground-based laser propagator, the pointing accuracies of the mirror itself on the spacecraft, and as well calculating the distance that you have to lead the spacecraft as it comes over the horizon. It's farther away from you. The distance is farther, so to accommodate the speed of light, you have to lead it more. As it comes overhead, it's closer. The speed of light, because of your adjusting for the speed of light, you don't have to lead it as much, and then as it passes over again farther away from you, you have to lead it more. Calculating all that, keeping that beam on that mirror, and then that mirror pointing down to the target board and down in Kihei was just an incredible feat, and I believe we won an award, the SPIE award, for that work in that year.
If you're having trouble imagining the billions of calculations needed to perform such a feat, Major Merrick has a simpler way of explaining this.
If you can, picture a guy riding on a motorcycle 250 miles away at 18,000 miles per hour holding up a dime. We were able to hit that dime as it went by us.
The applications for precision-guided laser beams go beyond using lasers as weapons. The military could use this technology to artificially illuminate a battlefield in the middle of the night. Or on the civilian side, the technology could enable scientists to extend daylight in parts of the world where there is very little. While this site is an Air Force research laboratory, it is also the center for a variety of civilian scientific research projects. One reason is the design of the telescope, which allows scientists to feed the telescope's images into multiple research environments.
The light is collected at the primary mirror through the telescope, and it goes through what we call the coude path. Coude is French for elbow or to bend. And what we're doing is we're bending that light down to there's 7 experiment rooms down underneath the telescope where experimenters can set up their experiment, whether it be a laser experiment or a seeing experiment, whatever, and whether it be astronomical for universities or for Air Force missions.
Building such a sophisticated technology installation here on the small island of Maui was no small task, especially since the telescope's design had to ensure there was virtually no vibration from the surrounding support activities.
We basically poured 12 million pounds of concrete and steel in a center pedestal within the building. We put a cone structure on top of that, and the telescope is mounted on top of that cone structure. The reason why we did this was to try and eliminate as much vibrations as possible. We then stepped back 2 inches and we built an outer building where all of our mechanical equipment is then located. Anything that vibrates is mounted on that outer portion of the building, so no vibrations would be induced into the optical system.
The Air Force's extraordinary ability to see things in space from their location here on Haleakala in Maui has had some very practical applications for NASA's Space Shuttle program. This is a picture the Air Force telescope took of the John Glenn shuttle mission. This is the shuttle tail in its normal flying position, which is upside down.
When the John Glenn mission went off, there was they had indications, I believe, there was a problem with the door at the tail of the space shuttle. We were contacted by NASA. Everybody was being contacted by NASA from that standpoint, but we were contacted by NASA to take images of the space shuttle to see if we could see anything at the tail of the space shuttle. We took those images. It was during the daylight with our daylight imaging systems, and we have to perform some special processing on those images. With adaptive optics, we try to take out the problems with the atmosphere with a deformable mirror. On our daytime imaging system, we don't have adaptive optics. We have to do processing on the individual frames themselves. By looking at those frames, we take out the blur, we take the average basically of what's going on in those frames, sharpen those up, and then we had a very good product that we delivered to NASA to help them determine that everything was okay with the John Glenn mission.
Another unique activity here at the Air Force Research Laboratory is a new program for the Jet Propulsion Lab designed to track asteroids which could potentially threaten the Earth.
One of the activities that we're hosting is this JPL experiment, the Near Earth Asteroid Tracking System. We have a package on one of our telescope mounts that is taking data through a wide field of view camera to look for asteroids. They take this data and compute whether any traces or tracks that they see are known asteroids or compute to known trajectories, or whether they're new asteroids, and based on the amount of reflected light that they see, the size of those asteroids and if they may be hazardous or not, depending on their trajectory and how big they are.
One of the natural assets that brings tourists to Hawaii is also bringing another high-tech industry to the islands. The asset is sunshine, and the industry is biotech farming. This is a microalgae farm using a new technology called closed pods. Up until now, microalgae was grown in open ponds, just as in nature. But that's not a very efficient way to grow microalgae. If you can put them in these spherical closed domes, you can increase the exposure to sunshine, reduce the exposure to contaminants, and grow better, cheaper microalgae. The mature microalgae are used in new health supplements such as Astaxanthin, which is an antioxidant. Research has shown that Astaxanthin is 10 times more effective than beta-carotene and 500 times more effective than plain vitamin E. These microalgae are also used for a health substance called spirulina, which is rich in vegetable protein, and for another nutraceutical called snow algae or lactanase, which makes baby formula more like real mother's milk. The design of these biodomes was the result of extensive computer modeling in the field of fluid dynamics. This photobioreactor technology is the brainstorm of a Japanese physicist, Seishiro Hirabayashi.
Our dome system has many advantages. One is this is closed system, so there's no contamination. So we can get a high quality product. And also we have temperature control systems, so we can control the temperature to some extent. And also we have special mixing systems. So production effectiveness of productivity is very good. Yes.
In fact, productivity is so good here that it takes only 10 days to turn raw microalgae into a mature product that is worth 5 times more than it was when it first arrived. One of the reasons Hawaii is pursuing the high-tech industry is because its traditional agricultural businesses are declining. This is a rusted-out sugar processing plant on Maui. With increasing competition from low-cost foreign producers, Hawaii's pineapple and sugar plantations are under pressure and in some cases closing down.
This is a power source which converts the power from 12-volt battery.
One of the weapons in the battle to keep Hawaii competitive in agriculture is technology. This is a sugar plantation on the island of Maui, run by the Hawaiian Commercial and Sugar Company, HCS. One of the challenges for sugar growers in Hawaii is to get the water in the mountains down to the sugar crops in the plains. To get good quality sugar, you need just the right amount of irrigation, and that means knowing where the water is and how fast it's flowing. HCS is trying to solve that problem with a new high-tech approach that uses solar power, wireless technology, and speech synthesis to provide managers with up-to-date information on irrigation flow.
The problem we're trying to solve is trying to find a more efficient way of getting the harvested surface water from the East Maui watershed area over here to the sugarcane and the Central Valley. We have domestic users here, also in the upcountry area. And basically the problem is just trying to get that water here as efficiently as possible and being able to monitor that accurately.
For years, they used a somewhat primitive technology solution to get information on water flow, but it depended on a very vulnerable network of power lines and communications lines.
That system is good, but it is unreliable sometimes because some of the more remote stations are out in the forests, and if you get branches from trees or trees itself coming down on power lines or on the telephone lines, you'll snap a line and you have no service there. So you need to actually get out into the forest and drive around and follow this and troubleshoot and look for the broken line, repair it, and then you get your system back online.
The old system here depended on a network of sensors which sent out beeps to the local operations office. The supervisor had to count the beeps and then correlate them with water level numbers in a printed manual. If a storm came along and blew down a few trees, odds were high that the lines would go down, and days would go by before the network could be repaired. Now, using speech technology and the wireless network, operations supervisors are able to get real-time data, more accurate data, and not have to worry about the next storm.
72.67 million gallons.
The demise of sugar in Hawaii is also affecting the energy industry here. In the old days, when sugar was king, the sugar plant waste was used as fuel to generate electricity for the islands. Fewer sugar plantations has meant less sugar waste to burn, and that means Hawaii has had to find new sources of energy.
Yeah, that one opened up, yeah.
Here on the Big Island of Hawaii, engineers like Lisa Dangelmeyer are working to manage new alternative energy resources in a way that could be a model for communities on the mainland which are facing a shortage of energy. Hawaii, in fact, has proven to be somewhat of a laboratory for energy research, since its very isolation means it can't solve an energy shortfall by temporarily borrowing electricity from a nearby state. That means Hawaii has had to develop the most reliable energy grid possible and develop energy management technologies which may be helpful in the other 49 states. For example, the network management software here takes only 2 seconds to report back a problem anywhere on the grid, half the time it would typically take at a mainland power company.
As an island operation, there's a couple of things that make that a unique challenge for an electric utility. One of the challenges is that we're physically a smaller grid in terms of the total amount of what we call inertia on the grid. The inertia is what stabilizes your system frequency. So if something should happen, like let's say a generator should trip offline, on the mainland, first of all, that would have a smaller impact on the frequency because the total inertia would be higher on the mainland. And then the other thing that would happen is on the mainland, the tie lines would automatically pull in power from neighboring utilities.
Hawaii has also escaped the disruptive aftermath of utility deregulation. It is still the power generator and the distributor, so it continues to focus all of its effort on only one goal, serving the customer.
if we don't have enough power here, we just don't have enough power. And there's no option, there would be no option but to not serve some of the customers eventually. You know, we haven't really had that situation very often. But on the mainland, it's not so much that they can't get power at this point, but how much are they willing to pay for it? And the price, I guess, has gotten very high. So the utility has to make a really difficult situation of what can they afford before they turn out the lights. We're still keeping the lights on is our focus.
One of the most significant energy experiments in the world is taking place here on the Kona coast of the Big Island at the National Energy Laboratory of Hawaii, known as NELA. Using computer-controlled flow systems, the scientists here are generating electricity from the ocean, using the temperature differential between the warm water on the surface and the cold water on the ocean floor to create what may be the most viable source of energy for the future. This technology weapon to take on OPEC is called OTEC.
The technology that we're developing here is called Ocean Thermal Energy Conversion, or OTEC. And OTEC uses the temperature difference between the surface water of the ocean, which here in Hawaii is nice and warm, and the deep water in the ocean, which is cold everywhere. And that temperature difference can be up to about, typically here is about 20 degrees centigrade or about 38 degrees Fahrenheit. And that temperature difference is enough to allow us to generate electricity from the temperature difference.
One of the main benefits of OTEC technology for generating energy is that the ocean is the world's most abundant, reusable, clean energy source.
The OTEC resource is very, very large compared to other alternative energy resources. If you take photovoltaic cells and spread them around on the land, you won't have nearly as much total potential energy as you can get from the surface, the warm surface layer of the ocean. The sun keeps shining, the ocean is a pretty efficient converter, and we can keep the energy stored in the ocean and use it as we need it. So it's a very efficient system. It also is environmentally very benign.
Right now, OTEC is still a relatively inefficient source of energy, but with fuel prices rising, it may not be long before OTEC becomes the primary solution to the world's energy problems.
The problem with OTEC, if you will, is that it is inherently a large-scale technology. It doesn't really work well until you get above 50 megawatts in size. Right now we're sort of at the experimental scale. We're just planning a 1 megawatt plant. So we've got a long ways to go to get to the full scale. And the thing that will make that happen more quickly is when the energy prices go up. We expect that the price of oil will increase, and when it gets up to, let's say, $50 a barrel, then the investment that's required in this technology appears much more promising.
The OTEC project is located here on the Kona coast of the Big Island of Hawaii because of its unique geography, almost constant sunshine, and a very steep coastal cliff, which gives scientists here easy access to the warm water of the surface and the cold water thousands of feet below the surface. Also, easy access to deep water right off the coastline is a boon to the nutraceutical industry, the people who harvest nutritional supplements. The deep water here is amazingly clean and provides a perfect place to grow a variety of health supplements, including astaxanthin and something called spirulina.
Spirulina is a health food supplement which is grown by our largest tenant, Cyanotech, and they sell it all over the world. I'm not sure, they were for a while the largest producer in the world. They sell spirulina. It's a marine microorganism, it's a microalgae that has a spiral-shaped cell, hence the name, and it is very rich in nutrients and vitamins, so people like to take it as a health food supplement.
Finally, this unique ocean environment on the Kona coast of Hawaii is good for something else.
We have a company growing Maine lobster that they bring in from Maine. Right now they're selling the Maine lobster wholesale. They're a wholesaler. They sell them retail to restaurants and to stores. And those lobster are just brought here for a little while. The same company has developed the technology to grow lobsters from eggs using the cold water, and they can actually greatly improve on nature. They can actually grow lobsters to a 1 pound size in 3 years or so, compared to 7 years or more in nature. They basically they eliminate the hibernation periods in the wintertime.
That's it for part 1 of our special series on high-tech Hawaii. We'll have lots more to come next week, including Hawaii's first silicon chip manufacturing facility, a visit to a world-class network test company in Honolulu, the building of Hawaii's first information age city, the search for exosolar planets at Mauna Kea, and new technology for predicting earthquakes and volcanic eruptions. For the Computer Chronicles, I'm Stuart Chaffee in Hawaii. The Computer Chronicles is brought to you by RonDiamond.com, the oldies site on the internet. Music and memories from the 50s, 60s, and 70s, not just another jukebox. Additional support comes from the law offices of Ivan Hoffman, Lawyering with Integrity, for internet law, copyright, trademark, and other intellectual property law. And by TechWeb for up-to-the-minute technology news.
To purchase a videotape copy of today's program, call toll-free 1-888-310-7850. Please specify the show number and the topic.